Hi all, this is the practice problems 21 from section 5.5 on L'Hopital's rule. So remember, we can use L'Hopital's rule when we have either 0 over 0 or infinity over infinity. So when I look at number 1, I'm going to start by plugging in that 1. So the natural log of 1 is 0. And when I plug in 1 minus 1, that's also 0. So this is type 0 over 0, which means it's eligible for L'Hopital's rule. So by L'Hopital's rule, this is equal to the limit as x goes to 1. And I take the derivative of the top and the derivative of the bottom. So this is 1 over x all over 1. And when you plug your 1 in there, that's going to be 1 divided by 1 divided by 1, which is just 1. For number 2, when you plug in infinity here, your e to the infinity goes to infinity. And the x squared also goes to infinity. So this is eligible to use L'Hopital's rule to find the answer. Keep in mind, when you have 0 over 0 or infinity over infinity, you don't know what the limit is. It's an indeterminate form. Could be anything. So our more work here is going to be using L'Hopital's rule. So this is the limit as x goes to infinity. And I take the derivative of the top and the derivative of the bottom. So derivative of e to the x is e to the x. Derivative of x squared is 2x. If you plug your infinity back in again, you're still going to get infinity over infinity. So that means we can use L'Hopital's rule again. And the derivative of e to the x is e to the x. And the derivative of 2x is 2. So now when I plug in, I get e to the infinity over 2, which is infinity divided by 2, which is still infinity. So you can use L'Hopital's rule as many times as you like, as long as you still have a form that meets the criteria. Okay, now here's one where we don't quite fit the criteria, at least not yet. So when you plug in the 0 here, the x goes to 0, but ln of 0 goes to negative infinity. So you have a 0 times infinity here. So in order to use L'Hopital's rule, I have to turn this into a fraction. So what I'm going to do is I'm going to keep the natural log on the top, but I'm going to move the x to the bottom by making its exponent negative. Right now it has a 1 exponent, so if I move it to the bottom, that's a negative 1 exponent. And then, if this is really the limit as x goes to 0 from the right of ln of x over 1 over x, and if you plug in 0, that's going to be infinity over infinity. And so that means that we can use L'Hopital's rule. So we can take the limit as x goes to 0 from the right. Derivative of the top is 1 over x. Derivative of the bottom is negative x to the negative 2. And when you think about this one, this is 1 over x divided by negative 1 over x squared. And if you flip that bottom one up, this is going to be the limit as x goes to 0 from the right of 1 over x times negative x squared over 1. And that just turns out to be the limit as x goes to 0 from the right of negative x. And when you plug in 0, you get 0. All right, here's another one that's similar where we've got something with multiplication. So if thinking about letting x goes to infinity, this will become infinity. And the tangent of 1 over x is going to go to 0. Tangent of 0 is 0. So this is your indeterminate form of the type infinity times 0. And I'm going to move something to the bottom. So what I'm going to do is I'm going to keep the tangent of 1 over x. And I'm going to move the x to the bottom again by making it x to the negative 1. And that's going to give me a 0 over 0. And so then by L'Hopital's rule, we get the limit as x goes to infinity of derivative of tangent x is secant squared of 1 over x. But don't forget chain rule, you got to multiply by the derivative of 1 over x, which is negative 1 over x squared. Right? 1 over x is x to the negative 1. So it's negative x to the negative 2 or negative 1 over x squared. Same thing on the bottom. The derivative again there is going to be negative 1 over x squared, which notice these two pieces are going to cancel out. And what we have left is just the limit as x goes to infinity of secant squared of 1 over x. And when you plug in infinity here, you get the secant squared of 1 over infinity. The 1 over infinity is 0. So this is the secant squared of 0. And secant is 1 over cosine. So this is 1 over cosine squared of 0. And cosine of 0 is 1. So you end up with 1 in this particular case. And while you're not responsible for 5 and 6, I will kind of show you what goes on here. So in this case, you end up with the type where it is infinity minus infinity. So what we're going to do here is we're going to factor out an x. And so what we do is we make this the limit as x goes to infinity. And I'm going to force factoring out an x. So that leaves me with 1 minus natural log of x over x. And what happens here is if you plug in infinity, this is infinity times 1 minus, and infinity over infinity, that's actually going to turn out to be, I believe, 1, and when you subtract it, it's 0. So what we want to do is, first of all, we need to figure out what this limit is here. So let's take that to the side and figure out that one. So if we take the limit as x goes to infinity of ln of x over x, that's infinity over infinity. And so we want the limit as x goes to infinity by L'Hopital's rule to be 1 over x over 1. And when we plug in 1 over x here, we get 1 over infinity, which is 0. Okay, so it turns out to be 0. And so now we know that this is the limit. This will give us infinity times 1 minus 0, which is infinity times 1, which is just infinity. Okay, so it kind of gets us out of that situation. So you force factoring out an x. In number 6, you actually get to factor out an x just naturally. So this is the limit as x goes to infinity of x times e to the 1 over x minus 1. So what happens here when you plug in the x, this is infinity. And when you plug in infinity, 1 over infinity is 0, e to the 0 is 1, 1 minus 1 is 0. So we actually get an indeterminate form here with infinity times 0. So not only do I factor it out, but then when I factor it out, I'm going to move that x to the bottom. So I'm going to have e to the 1 over x minus 1 up top and an x to the minus 1 on the bottom. And that's going to put me in a situation where it's 0 over 0. So then we can use L'Hopital's rule to take the derivative of the top, which is going to be e to the 1 over x, times the derivative of what's in the exponent for chain rule, which is negative x to the negative 2. Derivative of the bottom is also negative x to the negative 2. So just like in that one example before, those two parts will cancel. And I'm left with the limit as x goes to infinity of e to the 1 over x. And when you plug in your infinity, this gives you e to the 1 over infinity. 1 over infinity is 0. E to the 0 is 1. So I get 1 for number 6.